We'll talk about the cell-mediated side. So what we talked about up to now, humoral, all antibodies. That's all they're doing, producing antibodies, either with the help of a T cell or on their own. So the thing about a T cell is it's not producing something like an antibody that's that's soluble. It's going to end up in your bloodstream and into all sorts of tissues and everywhere. It's not a systemic effect. It's more localized. What they're going to have to do, the T cells are going to have to interact with the tissue itself. So they have to get to the tissue and then sit alongside the tissue and bombard it with toxins.
That's why they kind of are, again, like checks and balances to the B cells, because they're just going to be stationarily there checking on.
The B cells can stay in the lymphatic system. The T cells have to get out there into the tissue to be able to do anything.
I have a question. Are B cells creating antibodies?
Yeah, well, the B cells themselves aren't, but they proliferate into the plasma cells. Right?
So is that on that chart where it had like 4 and 5A and 5B?
So B cell sees the antigen, it becomes activated, and then proliferates and differentiates into the plasma cells, which produce the antibody, and also the memory cells.
So on that chart that was a little bit further down where it had like 4, 5A, 5B, and all those steps of... So when it gets to 4 and 5A and 5B, are they plasma cells now?
Oh, you... 4A...
It's
Are you
right
talking-
before this one.
What's before?
Yeah, that one.
Oh, this one. Oh, I thought you were talking about fragments or something.
Oh,
Okay, sorry. Yeah. What's your question here?
so where in this chart does it become a plasma cell?
After this.
Oh,
just the
okay,
activation part.
okay.
Yeah.
Thank you.
Yeah, so I'm talking about activation in this. So here we have activation here, but this part is activation. Okay. So we're talking about the T cells now. So they mature in the thymus. Oh, great, because I can remember T and thymus, so I can possibly answer another question here. Relatively easy if you can remember bone and B cell and T and thymus. So anyway, I'm just trying, I already give you my Gandhi trick, so I'm telling you some other tricks. Here, so two subsets of the lymphocytes. There's the cytotoxic T cells. These are the ones that are going to lie next to a target cell, bombard it with toxins, and kill it. The description is in here. Cyto means cell, and toxic to cells. Helper cells we've already met those along the way here. They're going to help they're going to help the B cells become activated if they recognize the particular antigen part that's displayed on the surface. We've already gone through that. And both these cells have the T cell receptor on the outside, so there's multiple copies of that. It just looks like one arm of an antibody. The third subset are the regulatory T cells, and what they're involved with is, calming down the immune response so it's not inappropriate, and also preventing you from mounting an attack against your own cells. So there are some autoimmune conditions where that's what happens, is the immune system starts to attack your own tissues. And again, coming attractions, we're going to talk about that on Thursday. Thanks. So for the T helper cells and the cytotoxic T cells, they have to be activated. But what's going to activate those? It's not going to be a B cell because the B cells are activated by them. So it's the dendritic cells that are going to be important in activating those. So what happens is the dendritic cell is going to present the T cell. Again, we learn that the T cell something has to be presented to it for it to become activated. In this case, they're going to be activated by the dendritic cells, and then once they're activated, then they proliferate and differentiate. The T cytotoxic cells are going to respond to intracellular antigens, and then that's going to induce the cell to find a cell that has that antibody or that antigen and destroy it. The T helper cells are going to affect both the cell-mediated and the humoral immunity. So they're able to activate B cells, which we've seen. They're able to activate macrophages, and they produce cytokines that support other T cells. The T cells also are going to produce memory cells. So not only do we have memory cells that produce antibodies in the B cells, but we have T cells that remember what they've seen too. And so both of those parts are really important to the immune system. When they first started to develop the COVID-19 vaccine, all you heard about is the antibody levels that people had, but then they started to move over and look at what what the levels of the specific T cells were too. So just to summarize what we've talked about and give you a picture is here we have a dendritic cell. That's going to activate the T cells that are going to bind to antigens that are being taken up by the dendritic cell and expressed, displayed on the surface. So that can activate the naive cytotoxic cell, and then we have these activated cytotoxic T cells. They are going to find the infected cell that of your body. Maybe it's infected by a virus or a bacteria, and then they're going to deliver these what they call death packages, enzymes and toxins that will kill it. So it all starts being activated by a dendritic cell. Then we have the T helper cells, and they're going to be activated by an antigen displayed by the dendritic cell, and you're going to have mature T cells. They're going to be able to deliver cytotoxins that activate macrophages, make macrophages really angry and active. The other thing they can do, is they can activate B cells when the B cell is displaying an antigen on its surface in its major histocompatibility protein, and then the activated T cell will the T helper cell will then cause the B cell to proliferate into producing the plasma cells, so we have the antibodies. So this is probably the best diagram to show you how all these cells are coordinating their activities. Does anybody have a question on these? Is it starting to make sense? It doesn't have to completely make sense in here, but if you're making a few connections as to what's going on, you're in good shape. Questions, comments? So as we said before, the T cell doesn't interact with the free antigen. It has to be presented to it, and it has to be presented on the major histocompatibility complex of the presenting cell. So there's two types of major histocompatibility molecules. There's the class 1, which present endogenous antigens, in other words, antigens made within the cell. And then there's the MH class 2, exogenous antigens, antigens that are being taken up by the cell. And so this is sort of a rough diagram, but this is a more realistic diagram, which shows, they have a constant region and variable region. So these receptors just look like one arm of an antibody. They're not being produced, they only stay on the cell, and they are waiting for something to be presented to them. So how we activate T cells is with the dendritic cells, which we talked about. They're going to be in the tissues. They've got these tentacles all over the place, just surveilling, looking for something that looks out of the ordinary. You're also going to find them in mucosal barriers and in the respiratory tract. So they toll-like receptors are on the surface. If pathogens are detected, then they're going to take up more material. Then they're going to travel to the secondary lymphoid organs. And they're going to produce co-stimulatory molecules signaling danger. And they're going to present on both the class 1 and class 2 MHCs to the cytotoxic and T helper cells, which will cause them to be activated. Those are the dendritic cells. So you can see they're surveilling, and then they're moving into the lymphatics where they can activate the T and the B cells. The macrophages and the B cells are going to present antigens on major histocompatibility complex class 2. And so you can see how you can activate T cells with these different types of dendritic cells, and then also you've got the macrophages and the B cells.
Could you go back 2 slides, please? Class 2. So exogenous. So then exogenous. So it's taken up. It's not made within. Okay.
No. It's taking up antigen.
Okay. Yeah.
So here's a picture. Here we've got a dendritic cell. It's taking up the microbial products that it's noticed, and then it's displaying them on the surface. That's going to activate the T cell receptor here in a CD4. I should tell you, T helper cells are CD4 cells, and then CD8 cells are cytotoxic T cells. They're the same thing. They just like to call them by different names. I think I've scrubbed most of. We'll talk about CD4 cells later on when we talk about immune diseases. But it's part of what immunologists do is they take the same thing and give it a different name. So just so you don't get confused. So if they've been activated, then they're going to be. So if they're activated by these antigens, then you're going to have activated T cells. So that's how the dendritic cell is going to work. However, if the T cells, the receptors will not bind, then you have, again, we're back to this energic T cell that you're not going to be able to, they're not going to be activated, and they're not going to respond. And so, again, it's checks and balances. You have to have the antigen presented, and then it has to be recognized by the T cell. And again, you have billions of different T cells reacting to different antigens. If none of them react to it, then there's no further progress in the immune response. So the cytotoxic T cell, they are So all nucleated cells present peptides on the surface, and here we have a T cell with a T cell receptor. Here's a cell that's infected by a virus, and so there's viral proteins on the surface. If the T cell recognizes this, it'll become activated, the cytotoxic T cell, and then you will have the release of cytokines that will cause the death of this cell. And so that's the result of this interaction. So they have things like granzymes, proteases, cytotoxins, proteins that put holes in the membrane of that cell. And this works with things that are affected by viruses. It also would be a response against that cancer cell too. The CD4 cells, these are the helper cells. And so, yeah, I do have the CD4 in here, and then the T helper, H is standing for helper. So what you're going to have here is the naive B cell is going to bind to an antigen, take it up by endocytosis, and then the T cell delivers cytokines when it encounters the the antigen parts on the MHC class 2 of the B cell, and then the B cell is activated. So we've gone through this a little bit before. What we're talking about here is the role of the T cell, whereas before we were talking about the B cell, but it's the same thing. So some molecules, just a term you should know, haptens are molecules too small to elicit a response. So you generally need a large molecule to hang around to produce a response. So sodium chloride isn't going to be an immunogen. But a large molecule can be. Penicillin is relatively small, but causes an allergic reaction because it binds to a protein and hangs around. So that's where you get the allergic reaction to penicillin. So T helper cells also are going to activate macrophages. So the macrophage engulfs materials, and then it degrades them, presents them on its surface. Along comes the T helper cell. If the antigen, or part of the antigen that's being displayed, binds to the T helper cell, then it's going to deliver cytokines to the macrophage, and that's going to cause it to be activated and have more power, more angry, greater abilities to engulf and eat up bacteria or parts of toxins or something like that. The last one I think we're going to talk about, is a natural killer cell. So, somebody asks you what's a natural killer cell do, then you pretty much have the idea of what this is going to do. So, what this is going to do is it's going to induce death of antibody-bound self cells. So, if you've created antibodies against a foreign protein that's on the surface of your cells, say produced by a virus, so now you have antibodies all around the outside. And what you're going to have is that antibody-dependent cellular toxicity. They have Fc receptors for IgG molecules, and so when they see the antibody sticking out, the Fc end, the stem end, then they're going to bind to it, deliver perforin and protease-containing granules, and kill the cell. They also can, so this is one where you produce antibodies against a foreign protein on the surface of a cell. The antibodies are sticking there, and now that's going to attract this natural killer cell, which is then going to deliver a package of enzymes and toxins to kill that cell. They also recognize host cells lacking MHC1. And so here we have a cell that's infected by a virus, and the virus eliminates the MHC from the surface. This is recognized by the natural killer cell and say, well, I don't recognize this. It doesn't have the normal receptor on the surface. So then what I'm going to do is deliver this death package to it and kill that cell. And so those are two of the things a natural killer cell will do. So by this stage, it all should be clear, crystal clear in your head. Right? So to check yourself, you can look at this diagram. So here we have immature B cells maturing in the bone marrow. And so we have a naive B cell, and it comes in contact with an antigen. It will need a T cell to validate that if it's T cell dependent. If it's activated, it produces the plasma cells and some memory cells. Plasma cells produce the antibodies, which are going to bind it up and also mark it for those cells for destruction. So everybody should, we get that. The T cells are going to be activated by dendritic cells. And so we're going to either have C-type cytotoxic cells or T helper cells. The T helper cells that are being activated by the dendritic cell are going to, if they recognize the part of the antigen displayed on the MHC of the B cell, are going to be involved in activation of that. Then you're also going to have T helper memory cells. You will also have the ability of the T helper cells to activate macrophages when they recognize antigen presented on the surface of the macrophage. So helping the B cell response and also activating macrophages. Then the cytotoxic T cells are going to be activated by the dendritic cells, and then they're going to find any cell of your body that's infected with a virus, and then they're going to be able to mark that and come alongside and then deliver that death package to kill that off. So that's all there is. That's basically what we've talked about. This diagram helps you keep it in your head as to what's going on. Any other questions on this? Okay, so the way to study for this is start tonight. Because it isn't one of those things, I'll just flick through the slides an hour before the test. It is not easy. This is probably the most difficult. It's downhill from here. The rest of the stuff is really simple comparison.
Even with all the memorizing all those diseases that some of my classmates have warned me about.
Yeah, there's not a huge amount. There's a manageable amount.
Okay. Thank you, doctor.
You're welcome.